Hey everybody, this is Larry. This is day 21 of January here in the year 2024, which is always still adjusting to saying that. But yeah, here we're going to do a random algo problem that we haven't done before, so let's get it started. And we have 660, we moved 9. Yeah, okay. I mean, it's actually, oh, it is a premium problem. And apparently house, is that a thing? Anyway, yeah, also a lot of downloads. I feel like they give me a lot of download problems. So yeah, starting from integer 1, we move any integer that contains 9, such as 9, 19, you have a sequence. Given an integer, we turn the nth integer in the new sequence. Okay, and you have some big number. I mean, the first thing I would say is that this is going to be binary search, but it doesn't make it easy, though, unfortunately. The idea is that given any number as a guess, you can return what the inverse function, right, of what number or what place it is in the new sequence, and then given that, you should be able to kind of just like binary search, like I said. But of course that now becomes the trick question, isn't it? Right? Like, what is how do you get given a number? What is the sequence? And that is just equal to, of course, counting the number of numbers that have 9s. So we'll have to kind of think about it a little bit, but we can write out the structure while we do. So we're going to do binary search. I like big hands. And then for now, I'm going to just, maybe we can do a tighter bound on this. For sure we can actually, but I'm just a little bit lazy. So I'm just going to leave it like this for now. And then mid is, right? And now if good of mid, what does good mean in this case? So we have a target. So let's define these things. So basically another way to phrase this is that we want the first number such that there are n or n or more okay, fine, yeah, n or more numbers before target in the sequence, right? Just return true for now. But basically it's just saying that given a target number, return whether there are at least n or more numbers in the sequence before it, which is another way of saying that is its position. But yeah, so if this is good, it means that there are n or more. So that means that mid is a valid number for but we want to try something smaller to get it earlier. So we have right is equal to mid, else left is equal to mid plus 1, because mid is not good, because if you have too few, then you have to get bigger, and mid is no good. And then we just return left. So this is structurally what we want, but you know, this is not the easy, this is still a tricky part, right? Okay, so then now we have to try to figure out the part, right, which is how many numbers are there before target. How many good numbers are there before the target? And maybe, I don't know which way is easier, is either this one or the inverse, right? The inverse number of, like you have to either count the number of numbers that don't have 9s, or you have to count the number of numbers that have 9s, right? And I don't know which way is easier. I think one thing that I would lean toward a little bit is the inclusion-exclusion principle, but I feel like that requires like dynamic programming, and that becomes a little bit trickier. I think maybe there is a little bit easier way of doing it, but maybe I'm wrong on that. Let me think. Right. This is so kind of tricky, isn't it? I would like to, I think the reason why this is tricky for me is that I would like to do it without dynamic programming. But it might be that we need it, which is, it is what it is. Hmm. Yeah, right. I mean, for now, I'm going to do with dynamic programming. I feel like there is probably a easy way to do this, but that's an intuition. And I think at some point, especially if you're doing like a competitive thing, you just have to do what it needs to be done. So yeah, this is going to be a sort of a digit DP, I guess. So yeah. Okay, so yeah, so basically we can do C maybe is equal to count the numbers of just target, right? So now we can do C is greater than or equal to N, and that's pretty much it. Of course, this is this is a little bit trickier, right? So now I use a lot of help, so we'll see. So yeah, so now this counts the number of number of numbers with no nines in the number, right? So then here, this is the way that I generally do it, but I don't know if this is great. But yeah, now you have this number as a string, and then now you brute force the first number, right? Now and then you just kind of go and then yeah, maybe another calc function. So then I'm trying to think real quick. Do I need to put S in it? I think we do, because I do a couple of dynamic programmings. But okay, fine. So we have to count S from the first index that we're looking at, and whether I forget the naming of these things. That's why. So yeah, whether we care about the so the first one, something like this, right? So then now calc is going to be, given a string, given the index, and then given that this is, I forget what I always go, like strict maybe? I don't know, let's just go strict for now. And then basically S is the number string, index is the index, and then strict is just whether the prefix the prefix coming in is equal to the S sub index, something like this, right? And because that means that there's an additional layer of constraints, right? So this is now becomes a sort of a brute force digit by digit, hence the name digit DP, right? Basically, this is saying that, okay, if this is strict, then basically what we want to do is, like I said, brute force from 0 to well, technically 0 to S of index, right? So that this does not include S of index, and then oh yeah, we do maybe like total is equal to 0. Total we added equal to calculate of S index plus 1 to the, so that we can brute force the next digit. Strict is no longer true because these numbers are strictly smaller than S of index, and then we also add S index plus 1 true, and this is of course for S sub index number, right, as the prefix. It's not quite done yet. I think here we also have to do something like if I is equal to 9, then we kind of I mean, and technically, and yeah, basically we want to skip the 9, and we can skip the 9 by actually taking this and then making sure that this is less than 9, right? Yeah. And then now if S of index is not equal to 9, then we can kind of recurse on this one. And of course, you can this actually you could save some state here, but nobody is saying that these are all overlapping states, so you could actually multiply by this. But I generally don't do that optimization because I mess it up a lot. And usually it doesn't make it that much slower if you have digit TP, but that's just me. You should probably, if you want to stay clean, just multiply them. But when I need to optimize, I'll do it later. But for now, I just kind of, I like to write code, especially the first spin, as exactly how I have the algorithm in my head and not kind of prematurely optimize, right? Okay, so yeah, so it goes up to the index, and with s of index is not 9, then we do this, yeah. And then now if this is not strict, then you can go the entire range. So then now you have this entire range, and you just go up to 9, skipping 9. You can just do. True? No, it's false, right? And then, yeah, and that should be good. Right, we just kind of skip 9s. I'm not going to go over memorization for this video just because, I don't know, this is already kind of tricky. So I'm just going to do the lazy man cache, and then let's kind of give it a spin just to kind of, like, I feel like we already have issues with this one, so that's why. I actually also forgot to, I'm actually surprised this isn't for another type of error, to be honest. Like, wouldn't this access? I guess this stuff it doesn't want, but that's interesting. I actually messed up here because I think for the first. No, it could be 0. I was going to say leading zeros, but I guess 0 is just one fewer digit, so that's fine. But yeah, we actually have to do something like if index is equal to n, then we return 1, right? And we should be good. Yeah. I forgot that case. String index of. This is what I expect more, but did I mess up off by 1 somewhere? Oh. Well, n is not quite what I meant, because that's this. But I think I mean this n, but I don't know. Maybe it's too late to kind of convert. Okay. I mean, I knew that I might have issues. That's why I skipped the caching for now. Because digit TP is very tricky to get right for me. So yeah. But for me now, let me just YOLO. Well, not YOLO, but just like print out just as a debugging thing. I counts of I, and then kind of just debug it real quick, or like just kind of display whether this is right. So okay, 0. I might be off by 1 because of 0 actually. So there is maybe that, but that's an easy fix, right? So 1, 2, we skip the 9, so that's good. Do we skip the 19? We also skip the 19, so that's good. We skip 29, so that's good. I want to see 99 skipped, or 90 skipped. That, and I think it looks good. So maybe I am just forgetting that 0 is not in the sequence. So we have to do something like, so this is the count including 0. So then we could minus 1 for not including the 0. And I guess maybe that's good enough, huh? I didn't. Okay, because it was off by 2 before. That's why I had some weird thing, but maybe it was just exactly because n is equal to 9, so it was an exact boundary condition which I didn't anticipate. Let's give it a quick spin, and yeah, there we go. But to be honest, I'm not happy about using dynamic programming, as I mentioned. There should be an easier way to kind of do this, but I don't know, let me cheat a little bit and kind of look to it. I mean, yeah, this is one-line Java. I wouldn't be surprised. Oh, this is actually okay. I feel silly now. Yeah. So there is something, I guess. Yeah, huh. That is actually amazing. Okay, fine. I was thinking in my head whether you can remove this for any digit and not just 9. But I guess that's not true. I think 9 is special because now that you remove any 9s, it just becomes a base 9 number, and then you basically now convert this as the base 9 number, and that's it. That is so smart. But sometimes, I mean, yeah, I don't know. I think this is kind of one of those things where having the difficulty tag kind of hides it away from you. Because you're just not super like you get influenced like like in a way, you get influenced to not look for easier solutions because I was like, it's a hard. I guess this is a hard solution, but yeah, the base 9 thing is actually amazing. Is there? Yeah, the base 9 thing. This is also kind of thing. But okay, well now you wouldn't do this that way because that's too slow. I don't know. Maybe there is a cleaner way, but I am curious whether, like, if you want to say remove a 4, then can you? Is that the same logic? I guess so. It is just that then now you have to kind of renumber your input numbers, and then it's still just base 9. It's just that you have to kind of convert the numbers to base. Yeah, huh. It's just like you have different symbols, but it is the same problem. So I kind of did it to, I don't know. I feel like you know, at this point in time, and what I mean is 2024 January, I feel like we've been getting a lot of digital DP lately, so I think that's been influencing on my mind. But and also, to be honest, it is a good practice to kind of get this out, even though this looks so like whatever, as a result of everything being straightforward. Yeah, I don't know. I don't know how I feel about this one, but if you got the easier one, easier method, I hope I kind of gave you a way to think about this problem that is interesting. So yeah, I'll leave you with that. And that's all I have for this one. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.